Hey everyone, looking at class number 93, and today we're going to be looking at determining electric field strength. So we're going to do a little math here, make sure you have your calculator ready. So if there is an electrostatic force acting on an object, we did that last unit, that means there has to be an electric field at that point. Going the other way, if there is an electric field anywhere, then a charged object will feel an electrostatic force at that point. So here's our equation, it's pretty straightforward. Electric field strength, which is measured in newtons divided by coulombs, newtons per coulomb, is equal to the electrostatic force measured in newtons divided by the charge that's in the field, which is measured in coulombs. It's important to note that Q is the charge that is feeling the force. Okay, sometimes they might refer to it as a test charge, but it's the charge that is feeling the force. We measure electric field strength in newtons per coulomb or volts per meter. Generally, we use newtons per coulomb though. So let's do a question here. So I already worked this one out, but follow through it on your own. So in this diagram below, we have an electron. So right there, you know Q. Q is negative 1.6 times 10 to the negative 19 coulombs. It's an electric field. We have two parallel plates. The voltage is 40 volts. And the magnitude of the electric force is 2 times 10 to the negative 15 newtons. The magnitude of the electric field strength between the charged plates is blank. So whenever you see magnitude, just make sure you make your answer positive. So you have E equals Fe over Q. We're given the force. We have the charge. Hardest thing is figuring out the charge because it's an electron. We get negative 2,500, or excuse me, 100 newtons per coulomb. All right, and make it positive because it just wants the magnitude of our answer. These solutions are on Canvas, so I'm not going to go through each one. Just read them. Make sure you interpret why the givens are what they are. Again, for number 5, we have an electron, so we know Q is negative 1.6 times 10 to the negative 19. That is on your reference table. Make sure you know where to find it. It's an elementary charge. Next one, we have a proton. So again, it's a very similar question, but now we have a proton, but that's just positive 1.6 times 10 to the negative 19 coulombs. Again, on your reference table, it's called an elementary charge. Number 7, just one thing about number 7 to be mindful of is that the net charge is given to you, Q. You're given the force. And it says it's placed near a negatively charged metal sphere. That negatively charged metal sphere, that's what's creating the electric field. It's not Q though, because Q is what's fueling the field. Notice how it says the net charge experiences an electrostatic force. So that is the charge that is feeling it. That's the one you use. Now these next two are a little bit more challenging. Definitely work through the math on them because the math is generally where people mess up here. So the givens aren't too bad, but you have to solve for Q, and Q is in the denominator. All right, so you have to work on your cross multiplying here and make sure that you're able to get the answer in coulombs. All right. This one over here, you are given the electric field strength, and you're told that we're dealing with electrons, so you know the charge of an electron, because it's asking about the electrostatic force on each electron. So the Q is just one single electron. Negative 1.6 times 10 to the negative 19 coulombs. Find the electrostatic force, comes out to be negative, but again, it wants the magnitude, so just make it positive. There you go. All right, so just make sure you're able to work through these. They're not too bad. They're basically just plug in and solve. Toughest thing is knowing that what the charge is. Okay, sometimes it's not given to you, but if it's an electron or a proton, you know the charge. So this is a question we've seen before. So let's go through it bit by bit. So we have an oil drop floating here between two charged plates. Gravity pulls it down, Fe pulls it up. We are told something very important, that it is motionless. That tells you that the electrostatic force and the gravitational force must be equal. Really, really, really important. All right. So the first thing we have to do is solve for the gravitational force, Fg, on the oil drop. So we know that Fg is equal to mg. This is on your reference table. G equals Fg over m, cross multiply, Fg equals mg. Well, what do we put in there? Well, we know the mass of the oil drop. It's given to us. 1.96 times 10 to the negative 15 kilograms, multiplied by G, which is 9.8, and you should get an answer of 1.92 times 10 to the negative 14 newtons. Next one asks you to find Fe. Well, you know it's equal to Fg because it's motionless. So you just write that down there, just carry it down. The last one here says, what is the net charge on the oil drop? Well, you know E. E is given to you right here. 4 times 10 to the 4th newtons per coulomb. It's given to you. Okay, you have it. Fe, you just got in the previous one. Solve for Q. All right. As easy as that. Just make sure you work through the math though and get a Q value of 4.8 times 10 to the negative 19 coulombs. All right. You definitely have to work on this in your scientific calculator. That's where most people make errors.